The second metaphor or simile that I want to offer you is one that came to me from Dr. Mary Mahler at the 6th Annual Psychopharmacology Conference put on by the American Psychiatric Nurses Association back in June of 2008 in Reston, Virginia. I will also upload a document that summarizes this material because I think it really is quite helpful. When we talk about the neurotransmitters and everything, first of all, we can talk about the captain of the team is the cell body. It's the source of information and protein synthesis, including DNA and RNA. If the axon gets separated from the cell body, it will die due to lack of protein synthesis. And it is the cell body that creates the neurotransmitter receptors. Then the pitcher of the game are the axons. They're responsible for the release of the neurotransmitters, the neurochemicals via the electrical discharge. Then the catcher are the dendrites, and they are those small branch-like projections coming off the cell body, and they receive the sensory input and they receive the information from other neurons and sensory receptors, and they transmit that information toward the cell body. The catcher's mitt is the presynaptic receptor. The synapse is the air between the pitcher, the axon, and the catcher, the dendrite. In this game, there are a team A, which are the good guys, the endogenous neurotransmitters of dopamine, norepinephrine, serotonin, acetylcholine, glutamate, GABA, the endorphins. And then there is the bad guys on team B, the exogenous neurotoxins, cocaine, marijuana, alcohol, nicotine, aspartame, white sugar, caffeine, heroin, amphetamines, LSD, ecstasy, etc., etc. There are 5 rules for the team members. The first is that it takes 5 half-lives for any substance to reach a steady state, and withdrawal occurs after a steady state. Half-life is the amount of time it takes for one dose of a medication or a neurotransmitter or neurotoxin to be eliminated. A steady state is the same amount of chemical remaining in the body after elimination has also occurred. And withdrawal is when a neuron has adjusted to a new steady state and the incoming chemical is no longer consistent. So in the game, there is the pitch, the ball released from the axon, from the designated pitcher. There is the catch by the receptor dropped into the dendrite. There is return, where those neurotransmitters are taken back up into the axon. There can be all sorts of interference that goes on, and you can read that in the handout. There's a timeout where there is adjustment of the number of gloves out there, the receptors. There is more receptors made, that's upregulation. Fewer receptors, they're closed down, downregulation. But what's really going on in the receptors? The action is not at the receptor binding site. The action is inside the neuron. And the stimulating or blocking of the receptors merely triggers a chemical cascade that ultimately affects the DNA protein expression. Axons from most cortical areas, as we've said, project into all of the other parts of the brain, thus dopamine, norepinephrine, etc. systems interact in common areas in the brain sites. There are both presynaptic and postsynaptic effects of drugs, amino acid precursors, and other chemical agents. All neurotransmitter output is ultimately modulated by calcium channels, and neurotransmitter release is a random quantum probability function. Quite complex. I've tried to make it a little simpler for you. Hope this has been enjoyable. I look forward to your feedback.